So now this is a question. So we have three equations. So this is equation 1, equation 2, and equation 3. So solving this using the matrix, the cofactor method now, is very easy. The first thing you need to do is to state the formula. So what's the formula? That x, remember x contains everything. Now we see we have a, b, and c. So that means x will have a, b, and c inside here, equal to what? Find a certain matrix A inverse and multiply it by b. So this is what all we need to do to find the answer for a, b, and c. Very easy. All we need to do, x is equal to, and x is just the variable a, b, and c. X here is carrying the everything here, a, b, and c. And now we need to find a, b, and c. A, b, and c is equal to, we need to find a certain matrix A and then multiply it by b. So now let's find our matrix A. Let's bring out our matrix A, and then when we find our matrix A, then we find the inverse and then we multiply it by b, and straightforward we get our answer A, b, and c. Very easy using the cofactor method. So now this is my matrix A. All you need to do is just copy and paste it here. See, this is 1, we have 1a, so we have 1, right? 1 minus 2 and plus 3. So that's going to be the first row, and then the next equation. So the first equation we have 1 minus 2 and 3. So just copy and paste it here. The next one, you guessed it, 3 minus 1 and 4, right? Now the last one, very easy, just exactly the way we did it 2 by 2. Very easy. Look at, just copy and paste. 2 plus 1 and minus 2. Very easy. That's our A. So all we need to do is find the inverse of this particular matrix, and then we'll multiply it by a certain matrix. So what is the matrix B now? So very easy. Matrix B is just this last part here. So matrix B will be 1, 3, and minus 1. You can see how easy this is. All you need to do is just set it up like this, and you've gotten your answer. So you find inverse of this, and then you multiply it by this, and then it is equal to A, B, C. So when we get, so A, B, C will be equal to the inverse. This is A now. We need to find the inverse like this. Okay, now so this is our matrix A. So to find the inverse, so the inverse of this matrix, like we always say, is going to be very simple. So once you find the adjoint, you multiply by 1 over determinant, like we solved in previous videos. So very quickly, let's find the determinant of A first before plugging in the formula. So to find the determinant of A, very easy. All you need to do is pick any row. I recommend the first row here. So let's use this first row. So now to find the determinant, pick this first row, and because we are picking the determinant, we need to multiply this by the cofactors. We need to multiply each element here, 1, minus 2, and 3, by the cofactors, and add and subtract, and get the scalar quantity. We pick this first one, 1. What is the sign? It is positive here, and it is positive here. So plus plus, and it is positive 1. So plus 1, plus 1. And then what is the minor? Now the minor, all you need to do is just delete the row and the column associated with this one. So delete the row and delete the column like this. And what are you left with? You are left with minus 1, 4, 1, and minus 2, like this. Now let's move to the next one. The next one is minus 2, right? Minus 2. Now minus 2, what is the sign here? Minus 2 minus, so it becomes plus, so plus 2. So you need to watch for the signs. And what is the minor? The minor, just delete the row and the column associated with and pick what's left. 3, 4, 2, and minus 2. And then the last one, plus 3. So 3 plus plus, so everything is plus 3. And what is the minor? So the minor, delete the row and the column associated with this element here. So delete this and delete this, and what's left? 3 minus 1. We've gone through this before, so I'm going to hurry up with this. So now that we have this, very easy, all you need to do now is break this down. Very easy. So every single thing is going to repeat. It's all a process. So anytime you see this long bar like this, all you need to do is just, okay, this, bring out this element here. So we have plus 1 outside, right? So plus 1, and then you multiply this times this, so it's 2, minus 2 times minus 1 is 2, minus, so when you multiply this by this, you subtract it from this times this, so this one too, this times is subtracted from this times this times is subtracted from this times this, and then you just multiply it by what's outside. Very easy. So like this one now, 1, open bracket and close bracket, this times is minus 1 times 4, which is 4. So now all you need to do is just subtract and multiply. So 2 times 2 minus 4, that will be minus 2, and minus 2 times 1, that will be minus 2. So that means here, everything here is minus 2, right? So that means minus 2 minus 28 plus 15. All you need to do is just join them together. Minus 2 minus 28 plus 15, that will be equal to minus 15. The scalar quantity associated with this matrix A, like this, the determinant, is equal to minus 15. So I've gotten this side out of the way now. What about the adjoint? So now to find the adjoint of the matrix, so don't forget that the adjoint is not the same with find determinant. Do not multiply the determinant, do not multiply the elements with the adjoint. So to find the adjoint, all you need to do is you need to find the signs first. So like I said, you can use it as a guide. So the first adjoint will be plus 1, right? That plus 1, and then find the minor. It's not the same. Don't multiply it plus 1. So find the adjoint. All you need to do is delete the row and the column associated with the element we are looking for. So delete this and delete this, and what I left with minus 1, 4, we've done this before, plus 1 and minus 2. So now the next thing to do is to find the next part, which is minus 1, right? Don't bother about adding this one. So just put minus 1 and then find the minor. So like I said, delete the row and the column, and then associated with this matrix. And what do we have? 3, 4, 2, and minus 3, 4, 2, minus 2. Alright, so you see that every single thing is going to look like this. You do every single, just like what we did for this and this, you repeat it for every single row. So the first row, second row, and third row, first row, second row, and third row. And we use this as a guide. So plus 1, minus 1, plus 1, that's the first row. Then the second row, minus 1, plus 1, and minus 1. Then the last row, plus 1, minus 1, and plus 1. Very easy. And then all we need to do is just find the minor. And to find the minor, delete the row and the column associated with that particular element. So let's just do minus 1 and plus 1 here, and here. So this one, to find the minor, very easy. All you need to do is delete the row and the column associated with that element. So delete this and delete this. Very easy. So what do you have? Minus 2, 3, 1, and minus 2, like this. Very easy, right? So now let's do this last one, this minus 2, this last element here. So we have plus 1 and the minor. To get the minor, delete the row and the column. You can see that we're doing exactly the same. Delete the row and the column associated with this matrix. And what do you have left? We have 1, minus 2, 3, and minus 1, 3 and minus 1. Very easy. So you can get all the minors like that. I've gotten mine. You need to be careful and cross check properly before you conclude. So the chances that you make error using a method like this is very, very high because of the iteration involved. The iterations are so much. Cross check every single minor that you have worked with. So now, like I said, we already treated this, how to find something like this, so you already know what to do. So this is it. This is how it looks like, the cofactor, the minor and the cofactor joined together. So these are the cofactors. And now the moment we multiply this by, and multiply this first row by this first row, you get the determinant. Multiply this one by this and add and subtract, you get the determinant, like that. So don't mix the determinant, don't mix these elements with these ones. These ones, all you need is the sign and the minor, and join it together and you get the cofactor. So now we have the cofactor. The adjoint is the transpose of the cofactor, right? To find the adjoint, all we need to do is transpose this matrix here. So turn the row into column, turn the row into column, interchange row and column. So let's try this first row. So turn this first row into the first column, like this. See, I turned this into a column. Now turn this into column 2. -1, -8, and -5, like this. Now the last one goes into the slot here. So that's all. So this is adjoint that we're looking for, and now we already have the determinant as -15. So now we can work with this. So all we've been trying to do is find the inverse. So now we already know that the inverse is equal to 1 over the determinant of A multiplied by the adjoint of A. Already have all these details. So the adjoint, this is the adjoint, this is the adjoint, and all we need to do is multiply it by 1 over the determinant is 1 over, so determinant is -15. So multiply this and you get the, so the moment you multiply them like this, you get this matrix here. So this is the inverse of the matrix. And now to find our x, which is our final answer, all we need to do is multiply the inverse by b. Remember, so to find our x, our final answer, all we need to do is multiply our inverse by b. So all we need to do is take this inverse and multiply it by b. So once you multiply this by this, you get the final answer. A, B, and C, you finally get them. So all you need to do is just take all the elements here and multiply by all the elements here. Take all the elements here, multiply by this. Take all the elements here and multiply by this. Very simple. 2 over 15 times 1 is 2 over 15. 2 over 15 times 1 is 2 over 15. And then plus the next one, 1 over 15 multiplied by 3. That would be minus 1 over 5. And then the next one multiplied by the last element here, -1. So all we're doing, we're trying to get the first row now. So we're trying to get the first row. So the last one, -1 over 15 times 1 times -1, sorry, that will be plus 1 over 15, right? So multiply every element here, 1, 2, 3, multiply them by 1, 2, 3, and add and subtract them. So once you do that, 2 over 15 minus 1 over 5 plus 1 over 15, so that is equal to 0. So our first element here is 0. Now for the last two, so this and this, so this has to multiply with this, and this has to multiply with this. This time this and this and this multiply by this and this and this. And if you work this, so here is, then the last one, now multiply everything here by everything here. -1 over 3 times this is -1 over 3. 1 over 3 times 3 is 1, and -1 over 3 times -1 is this. So multiply this times this times this over this times this times this. So make sure you watch the previous lesson on multiplication of matrix. I explained everything explicitly, how to solve multiplication like this. Easy. This dies with this, and very easy. So as you can see, we've succeeded in getting our final answer. So meaning our x, which is our a, b, and c, is equal to this. So let me rewrite x now. So a is 0, b is 1, and c is 1. So in like this. So you need to calm down with this method. You need to be patient with this method, because this method is really long, but it's full of mistakes that you have to debug. Alright guys, so that's it for this video, and let me know in the comment section, what would you like to see? What areas in maths do you have problems with? Let me know and I'll check it out, and I'll make videos for you guys. Of course, thank you for showing an interest in maths. Keep debugging that maths, and I'll see you guys in the next one.